proposes a multi-layered programmable blockchain, which implements different layers of strategy for different purposes. And it's been received with a lot of enthusiasm from the community. We have been acquiring a number of sponsors, a number of supporters throughout the years, which have helped us with this endeavor. And then at the same time, just this year, we also founded the Postgraduate National Blockchain Program, myself and Dr. Professor Viorel Negru, supported and accredited by the Ministry of Education and Research of Romania, and at the same time, held at the Western University of Timișoara, with the sponsorship and help of the ABEY Foundation, alongside Mihai Alisia, the co-founder of Ethereum, as part of the Ethereum Foundation. Now, our accomplishments over the years have been quite successful. I would say in just 6 months, we acquired 100,000 unique wallets. We've experienced a growth rate which was 8 times higher than Bitcoin's and 2.5 times higher than Ethereum's in the same time period. In 2019, the ABEY Foundation has been founded, and its purpose is to actually support us with the legal tackles that we have to undergo with when it comes to the research that we do. And currently today, our token is actually being traded on 3 different exchanges. Some of use cases for the ABEY technology: at its very core, the ABEY technology, the ABEY blockchain, has been adopted by aPay Systems, a payment gateway and processor based in Malta, which is delivering transfers of assets to various cryptos, various derivatives, and it also employs the use of credit cards and debit cards to be able to spend that crypto: UnionPay, MasterCard, and Visa. And the fact that our blockchain is suitable for such a high-performance environment where thousands of transactions need to be processed every second was one of the biggest supporting facts for us moving forward. In terms of research highlights, in 2019, we published a paper which is called Improving Blockchain Security, Validation, and Transaction Processing Through Heterogeneous Computing. It was published as part of Springer International Computational Intelligence for Security Information Systems. And we actually show how we can achieve an impressive speed up of the number of transactions per second by more than 100 times on just a casual computer by employing our heterogeneous computational models. For our technology showcases, we were present in Malta at the AIBC 2019 and the Singapore Block Show Asia 2019. In 2020, we organized our own security conference, which was called Security Advances in Computational Intelligence for Permissioned and Permissionless Blockchains, as part of the International Conference on Computational Intelligence and Security for Information Systems. This was published in Springer in the International Joint Conference with a number of other conferences. And also we organized the Advances in Computational, Symbolic, and Secure Algorithms for Permissioned and Permissionless Blockchain as part of the SYNASC 2020 with proceedings in IEEE and Explore Digital Library. When it comes to the research that we do, we tackle with many aspects, including e-commerce. One of them is actually showcased in this slide. And that is actually focused on governance. I'm not going to bore you with the details. Another aspect that we focus on was governance itself, which is a paper that we published in 2020 at the 22nd International Symposium on Symbolic and Numeric Algorithms for Scientific Computing. All of these will be tackled a little bit later on by my colleagues, so I'm not going to go into all the details about these. But the proceedings for these conferences were Web of Science, IEEE, Explore, Scopus, and DBLP. When it comes to the smart contract side of things, we also publish papers detailing a formal model for implementation of a metric-based virtual machine for smart contracts, high-performance virtual machine actually, published by SYNASC 2020, again, International Symposium on Symbolic and Numeric Algorithms for Scientific Computing, with proceedings in Web of Science, IEEE, Scopus, and DBLP. We had some very important breakthroughs when it comes to the smart contract side of things. One of the latest and most recent is a paper which we published called The High-Performance Native Approach to Adaptive Blockchain Smart Contract Transmission and Execution, published in one of the most highly sought computer science journals, Information Processing and Management, or an A ranking journal according to core rankings, and where we show how we can improve the performance bandwidth-wise of a blockchain, specifically ours, as opposed to Ethereum by 2 to 10 times. Another breakthrough that we had, also a recent one, is our own proprietary storage system, which involves dynamic storage methodologies, which is actually dedicated for the implementation of distributed applications in blockchains. It's called ABEY DB, And it's an interesting approach that we took, and we tested against the most powerful database storage systems that are in existence today. We performed multiple tests in various scenarios, and some of these tests have been quite impressive. For example, in this particular one, we achieved a performance which goes from 2 times to almost 40 times better than Ethereum's level DBs. In another scenario where we actually test the performance per memory footprint ratio, we can see that our blockchain is actually, in all scenarios tested, is actually better than Ethereum by 18 times to almost 183 times. Now, what this means for smart contracts and blockchains is that we're trying to resolve one of the biggest bottlenecks when it comes to smart contracts and their executions in blockchain, and that is low-level interactions. And such low-level interactions are usually the ones which are the culprit of technology nowadays, with I/O operations being almost at the core of security in many blockchains like Ethereum, with many of the research security papers which are focusing the Ethereum security being targeting this specific aspect. So that is exactly what we've been trying to solve here, and we believe we have done it quite well at this time. Another breakthrough that we had just recently is the implementation of our own virtual machine, which we have tested numerical algorithms on. And this is a recent paper that we've already sent for review, for peer review in one reputable international journal. And the performance of this virtual machine that we've implemented, as opposed to Ethereum's EVM, is about 107 times better when it comes to the actual runtime performance as opposed to Ethereum VMs, which I believe at this point makes it the fastest in the world. And also at the point ABEY, according to the results previously, is also the fastest storage system for distributed applications in the world that we know of. Our market value growth factor has also been impressive. In just the past 4 months, we've seen 1,200% growth after publishing the results that we've achieved. And that would put us, even though we're not yet listed on CoinMarketCap, it would still put us in top 15 in terms of market cap worldwide. In 2021, we're organizing our own international conference where we have a number of reputable international lecturers and academia participants. And for the research side of things, I will give word to my colleague, Alexis Pitaro, who will be telling you a little bit more insight into the type of work that we do.
Hello, thank you. My name is Alexa Lucas Pataro. I'm a research associate of the ABEY Foundation and a student at Western University of Timișoara. Today I'll talk about the research and development that we do as part of the ABEY project. But first, please allow me to introduce myself. I have been part of the ABEY project for almost a year, starting with research on smart contracts. Now I'm responsible for the research initiatives within the project, which includes taking part in studies that turn up into papers, and guiding students towards blockchain-focused research interests. Besides that, me and my team are involved in the development of the smart contract technology for the ABEY blockchain. Recently, our development team managed to implement a fully functional suite for compiling and executing smart contracts, which will be written in the C programming language and executed by a fast virtual machine. Now, I would like to run you through some of our recent research contributions, and in the end, I'll talk about the performance benchmarks of the ABEY virtual machine. Within the ABEY Foundation, we had some extremely solid research results, which have been peer-reviewed and were published, or are going to be published in reputable computer science journals and proceedings. Here I can mention the Information Processing and Management Journal of the well-known academic publisher Elsevier. I would also like to mention the International Symposium on Symbolic and Numerical Algorithms for Scientific Computing, or CNASC for short, whose post-proceedings will be available on IEEE Explore Digital Library. The first paper I'll start with is called Survey on Feasibility of Blockchains for E-Commerce, where we explore the blockchain technology in its current form and shape and how far it is from mass adoption in e-commerce. We selected 13 popular or innovative distributed ledger technologies and performed a comparison in terms of safety and liveness. We also propose an ideal model and compare it to the other platforms by using a general metric. In another research aspect we are interested in is governance within blockchains. And in our paper called Towards Efficient Governance in a Distributed Ledger System using High-Performance Computational Nodes, we made a review of current blockchain technologies that have a governance model employed. And we propose some special kinds of nodes aimed to solve specific problems. For example, we propose nodes to solve the programmability aspect of the blockchain, adoption, performance, and the consensus mechanism. Then we discuss the advantages and disadvantages of each approach. In another paper accepted at the same conference, we tackle some problem in smart contract design. The paper is called A Metric-Based Approach to Modeling a Virtual Machine for Smart Contract Execution. And here we define the virtual machine used for the execution as a deterministic state machine. And within the definition, we propose additional metrics for constraining computational resources, which we believe and prove to be more advantageous than the Ethereum gas model. We also discussed the importance of having a loosely coupled architecture, especially in the diversity of programming languages we have today in the blockchain area. In another paper called High Performance Native Approach to Adaptive Blockchain Smart Contract Transmission and Execution, accepted at the Information Processing and Management Journal, we aim to reduce the bandwidth as well as the storage requirements for smart contracts. Our method consists of new types of nodes that insert metadata into the blockchain at specific time periods. We also perform real-world experiments with genuine contracts and obtain significant results, which indicate a substantial bandwidth reduction of up to 90% in best case scenarios and 50% on average, which indicates that smart contracts are from 2 times up to 10 times more efficient bandwidth-wise. Besides that, we employ the most efficient storage model known for the metadata that we work with, a model itself proposed by Dr. Ciprian Pungila. Speaking of the performance and the virtual machine, recently we tested the execution time of the ABEY virtual machine and compared it to that of the Ethereum virtual machine based on an experiment. The experiment consisted of execution of a numerical algorithm, and it was done on consumer hardware. According to the results, ABEY virtual machine successfully finishes the execution in 8.2 seconds, while the Ethereum virtual machine takes around 880 seconds, which indicates that smart contracts on ABEY virtual machine are executed 107 times, up to 107 times faster than on the Ethereum virtual machine. That concludes my presentation. Thank you for your time and interest. Now I'll pass my word back to Dr. Ciprian Pungila.
Okay, and because we're very close to the end of the lecture, I want to emphasize the importance of the breakthroughs that we've had so far. It shows that the technology that has blockchain at its very core doesn't have to run on powerful servers or mainframe systems. It actually can run on casual notebooks, casual computer hardware, as long as you apply the proper computational models to achieve this. So because we are very close to the end, like I mentioned, I would like to announce the upcoming roadmap for 2021. We have a lot of great things coming in 2021, with white paper version 2.0 being the main focus of these new upbringings. And this would be a very good sign to all our trustees, to all our supporters, which have been anxiously waiting for this to be launched. We're going to bring a lot more new concepts into the white paper, a lot of the concepts that we've had researched and we had published so far, and we're very anxious to bring it to life. Thank you very much for your attention. It's been a pleasure. I hope you enjoyed.